Previous lesson, we looked at why chemicals are unstable or they are stable. In this lesson, we're going to look at one way that atoms can achieve stability by exchanging electrons with one another, ions. So since atoms are searching for stability, electrons can be taken and given away. If I'm an atom, I could take an electron or I could give them away. And that's how I can achieve stability. So when this happens, ions are formed. So when an electron is given away or taken in, that's when you form an ion. Because when you either give away or take an electron, the number of electrons then no longer equals the number of protons. Ions can either be negatively or positively charged. For instance, if I was to give away an electron, then I would have one less electron than protons. There would be more positive charges than negative charges. I would be a positively charged ion. If the opposite happened, I was to take in an electron, now I have one more electron than I do protons. So I have more electrons than protons, which means I will be negatively charged because there's more electrons. And so I'll be a negative ion. So positive and negative ions, here's the formal definitions and things for you. So positive ions are formed when unstable atoms give away one or more electrons to other atoms. So when one atom gives away electrons to other atoms or more electrons, then you form a positive ion. Now, since the electrons are negatively charged, it results in more positive charges because the protons don't change, the proton numbers don't change, compared to negative charges. So that's why they become positive ions, because there's more positive charges now than there were negative charges. So positive and negative ions. When we are talking about negative ions, the opposite happens. So when we have a positive ion, it gives away an electron. But when we have a negative ion, the electrons are gained by the atom. Before, we gave away an electron and we had an excess of protons. But now we're taking in an electron and we're getting an excess of electrons. So there's more electrons than protons. You get a net negative charge. That's why we get negative charges. How do we use the periodic table? Because this is our favorite tool as chemists. How do we use this to predict ion formation? So here I have my periodic table and I've zoomed in on chlorine. So in order to predict what kind of ions will form, we need to know about the outermost or valence shell of an atom. Okay, so we need to know about the outer shell of an atom in order to predict what kind of ion it will form. So the group number on the periodic table tells you how many electrons are present in the valence shell of the electrons in that group. You know what the groups are. Here's group 1, group 2, group 3, group 4, group 5, group 6, group 7, group 8. We know what the groups are. So they're just the column numbers. 1, 2, 3, 4, 5, 6, 7, and 8. That number tells you a lot more than just what column this particular element is in. It actually tells you how many electrons are in its outermost shell. If I look down this one, group 1, I can predict that lithium will have one outermost shell electron. Potassium will also have one outermost shell electron. Carbon will have 4 outer electrons in its valence shell, and xenon will have 8. So you can see that there's a lot of information that these group numbers can actually tell you. That actually helps us a lot. So using that knowledge, we can actually predict what kind of ion will form. So consider the Na atom. Let's look at the sodium atom once again. It's in group 1. So look at your periodic table at home. You can see that sodium is number 11. It's in group 1. And therefore has 1 electron in its valence shell. So in order to achieve a full outer shell, it can do one of two things. If I want to achieve full outer shell, I could either gain 7 electrons, grab 7 electrons from somewhere, or give away the 1 electron in this outer shell and lose that shell completely. So instead of gaining 7 electrons, I could actually just dump the outer shell. If you think about it, it's easier to get rid of 1 electron than it is to gain 7. The natural thing to do would be, let's go the easy way and say, get rid of that 1 electron. So you can see it's now getting rid of this 1 electron. And obviously because it's lost that electron, it's got more positive charges than negative charges. So it creates a net positive charge, which means that it becomes a positive ion. Now metals in general will create positive ions, while non-metals will form negative ions. That's in general. Sometimes there are exceptions, but most of the time that's true. So that concludes today's lesson on ion formation. We've looked at how ions can form by either giving away or taking in electrons, and what type of ion will form because of that. We've also looked at how we can predict what kind of ion will form based on the periodic table. And we can use that as a tool to help us solve problems. So move on to the question segment now and actually try and solve these said problems. So predict the type of ion chlorine will create and determine the charge of that ion. What type of ion will chlorine form and how big a charge would it have? Would it have +2, +3, -3, -64? That's our goal. So here's our lovely periodic table once again. You can see that chlorine is in group 7. So it has 7 electrons in its outermost shell. What are its options? It could gain 1 electron to make 8 in its outer shell, or it could give away 7. If you think about it, it's easier to get 1 than lose 7. It will try and acquire 1 more electron. Obviously, if it gets another electron, there's more electrons than protons, so it will be negatively charged. So it will be a negative ion. Now, since there's only 1 more electron than proton, the new ion will have a charge of -1, because we say each charge is 1, or is sort of 1 magnitude of charge. If you have 1 more electron, you have -1 charge of that ion. So predict the type of ion magnesium will create and determine the charge of that ion. So magnesium is over there in group 2. So magnesium has 2 electrons in its outer shell. Its options are to gain 6 or give away 2. It's easier to give away 2 than it is to gain 6, so it will give away those 2 electrons. Now, if it gives away electrons, there'll be more positive charges than negative charges, so it'll be a positive ion. And since there are 2 more protons than electrons, the charge will be 2+. So using the periodic table, explain why helium, neon, argon, and krypton are all stable and don't react with anything. So here we have them, helium, neon, argon, and krypton. Now all of these elements are in group 8. Now this means that all the members of that group have 8 electrons in their outer shell, or 2 in the case of helium. Since they all already possess the necessary number of electrons, there's no need for them to interact with other elements to achieve stability. And that's why they don't react. They've already got what they need, so they don't need any more. So they won't bother reacting with other elements because it's just not worthwhile for them. There's nothing for them to gain. So that's why they don't react. And that's why we sometimes call them the noble gases, because they're what each element is aspiring to become like. So here's the last question. What type of ion is carbon likely to create? So we have carbon. What kind of ion is it likely to create? Check your periodic table once again and you'll see that carbon is in group 4. So it can either gain or give away 4 electrons. It's got 4 in its outermost shell. It needs to make 8 or it gets rid of 4. To make 8 from 4, you need another 4. It can gain 4 electrons or give away 4 electrons. It's equally feasible to do both, gain or give away. The ion that carbon will actually form will depend on the other elements it's interacting with. If it's reacting with an element that wants to give away electrons very strongly wants to give away electrons, then it will likely form a negative ion because it will take those electrons in. If it's reacting with elements that want to gain electrons, it will then likely become a positive ion because it will want to give those electrons away. It depends very strongly on what type of element the carbon is reacting with. And it's the same for all of these going down. It's just a very interesting case of where we have equal numbers on both sides. So that concludes today's lesson on ion formation. We looked at why ions form and how they can be used to achieve stability. So I look forward to seeing you at our next lesson.